Okay, it's just after 11 o'clock, so I think it's about time I started the lecture. And thanks for coming along. And I've just posted in chat to say that, if you have questions about any of this stuff as we work through it today, please post questions in chat and I'll get to it in chat. And if I have to get to you afterwards by mail or in Teams, I can do that also. Right, this is week 9 and this is lecture 17. And we're going to be looking at working with software design patterns. And in particular, today, we're going to be looking at the creational design patterns. In fact, we're going to be looking at one of the patterns, and that's just the Singleton, as an example of, how we can get into real detail of designing classes. And we're interested in designing classes that are informed by the design patterns themselves, but also good design principles. And then we also want to think about some real world development issues as well. So what happens if we want to have good data management, something you call lazy initialization or eager initialization, and we want to think about threaded applications and the difficulties of actually moving from the structural design that we see in the pattern descriptions and the difference from those kinds of designs to real world applications. So we'll work right through the Singleton. We'll work through it to death of the Singleton. You'll be tired of Singletons by the time we're finished, but it should give you a sense of the kind of approaches that you need to look at for any of the design patterns that you want to work with. And I'll probably in the next lecture I'll do factories. I'll do factory and abstract factories in some detail as well. But we'll work through the one today then. So as I said, we're going to learn about this one of the creational software design patterns, the Singleton. And you've seen me talk about this before, and I mentioned it before. And you could use it in the current assignment that you're working on. You could, for example, have a canvas that's designed to be a Singleton and then provides all that functionality so that you can really only have one canvas and you can't just be randomly creating canvases every time you want to work with it. We're also going to see how the pattern can be implemented in C# using lots of examples, and there's lots of ways of implementing the Singleton pattern based alone on the structural description of the pattern. And then, you could do this in Java, you could do it in C++, and we're going to use C# example for our examples, of course. Okay, so just to remind you from last time that most of the examples I tend to use will be from this book, Dive into Design Patterns, and we'll use some of the code directly from there and some of the structural information and some of the diagrams. Again, you can check this out on refactoring.guru. You'll notice that I tend to use and have references at the bottom of the page here. So it would be a good idea to look at those references. Okay, so it's probably this particular one is the reference for this particular text, but it isn't the only text that I'm using as I work through this particular examples for Singleton. I will look at some others, and I will mention those as I go through, but just keep an eye on the bottom here and you'll always be able to click through and work with those if you want to get more detail on where I found the resources. I try to have a balance between something that's theoretical and something that's practical. And for now, I'm kind of looking at practical, accessible online resources that will be useful, rather than you having to buy and work through another heavy-duty textbook. I mean, you can do that if you wish, of course. It's nice to know that. Okay, so let's think about the creational design patterns first and foremost. Okay, so these patterns are concerned with the way in which objects are created in applications. So they reduce the patterns reduce the complexity and instability by creating objects in a controlled manner. And what would that be a problem, you might say? Because, we can create objects very easily just using the new statement. But actually, the new operator is considered harmful in terms of software design. That's one of the key issues around creational software design patterns. It scatters objects all over the application. So, you can have objects created absolutely everywhere in your app, and you have freedom if classes are available. You have the freedom to create classes. You have freedom to create subclasses. So it would be much better from a design perspective if object creation and disposal were managed in a controlled way. Now, I don't talk about disposal, but we could do as well. I mean, I found a couple of nice references on disposal of singletons, for example, but I didn't talk about it today. But you could look that up, and if you want to know more, I can send you some links. So I suppose what we're really concerned with is that over the lifetime of an application, then it can become really challenging to change the implementation because the classes become so tightly coupled. And we don't want this in terms of design, and we saw that when we talked about Solid previously. So it's possible to use creational software design patterns then to address the issue by decoupling the client entirely from the initialization process. So you essentially have all of the items that you need for creational of objects and so forth. So you, for example, will want to create shapes, for your current application. Then you could have a factory that generates shapes, and that's all set up in advance. And then you can use the factory to generate something rather than having to use new right through your application. Because and the problem is that you often work in teams, and you will trust the people in your team, but sometimes you might not trust the people in your team to actually use the code, the creational code or object code, and the way it was intended. And that might be, intentional misuse, or maybe accidental misuse. So, the more that you can do to control things, the better. Okay. Now, and there are lots of patterns that we can use for creational. We can use patterns like Singleton, which we're going to look at today. We can look at factory, an abstract factory, builder, prototype. There are lots of them, okay, and you can work through all of these. Again, if you go back to the textbook, it's a really good way to look at that. It goes through all the examples, gives lots of code, the structural, UML, everything, and it's all in one place. And if you don't want to buy the book, of course, you can just go to refactoring.guru. And there are other sites as well, but I just like that one. Okay, so let's think about the Singleton pattern. So the aim of the Singleton design pattern then is to monitor initialization of objects of a particular class by ensuring that only one instance of the object exists throughout the lifetime of the application. So it's either executing in .NET or it's executing in your Java virtual machine, for example. Okay. So the Singleton class then also provides one unique global access point to the object, so that each subsequent call to the access point returns only that particular object. So the core purpose of Singleton then is to centralize management of internal and external resources and to provide a global point of access to these resources. So for example, if you think about ASP.NET and look at the HTTP context class, that's an example of a Singleton. And I think I used that one last time in one of the lectures. So generally, the Singleton instance is created only when it's requested for the first time, and you gain access to the instance globally afterwards. Okay? Now, what's interesting, I suppose, about this here, about the core purpose, is to centralize management, okay, and to provide a global point of access to the resources. So what this is telling us is that the purpose, or the core purpose of Singleton, is to do two things, okay? It's got to do two things. And we'll come back to that a little bit later. If you remember, you try to remember this, because, we had a discussion on Solid at one point in terms of design, and what that told us fairly early on as part of design was that a class should do one thing, not two things. But here we are, using one of the core Gang of Four patterns called Singleton, and it's telling us our class should do two things. Okay, so just bear that in mind, and we'll come back to it a little bit later at the end of the lecture. Okay, so like all software design patterns, then Singleton has advantages and disadvantages. Now, I recommend that you research yourself for all of the patterns that, so it's in preparation for a module examination. I'll probably tell you the ones that I'm interested in. So if I cover these, I might not cover all the pros and cons or the advantages and disadvantages for these things or examples, but any method, any pattern that I go into in any amount of detail or reference, so I've been in Singleton today. If I use factories in the next lecture or something, then I would expect you to have done some work on this. Okay? So that's an issue that you need to look at. You have to understand the advantages and disadvantages. And also, it's important that you realize that care should be taken when these patterns are used in multi-threading environments. So in other words, when multiple threads must access the same resources to the same Singleton object. So this means that it could be very hard to test a singleton, and that becomes actually a bit of a problem with it, because a lot of test environments need to, subclass or the various classes create instances of objects and things for testing, and you'd have to be creative in terms of how you make that happen. So it can be an issue. But anyway, bit of work for you to do on your own study. I'd certainly recommend look up your own research. Now, that research could involve just reading some of that book, working through the website, knowing where to find it if you're ever asked about it. Doesn't mean that you have to memorize and learn all that stuff. There's a lot of patterns here, a lot of patterns to understand and come to grips with, understand the code. And I don't expect you to have these all in your head at all times. You need a bit of few, and over time you'll pick up some more. And as I mentioned in last week's lectures, not everybody knows all of these things all the time. You just have to you might be able to spot it and see what's going on, maybe even from the name, but names are very useful of classes, or some comments in there as well. But know where to find the information, and know this by working around that refactoring.guru website, for example. And that becomes your single point of reference. And you're able to look and understand how things are done. And if you're asked a question, for example, in an exam or your preparation for an interview, it should go to place. So have that, please, and it will be very useful for you. Okay, so let's have a look at the singleton. Again, you see that I do have a demo of this. So much of this lecture will be swapping back and forth between the slides and some of the code that I've written. Some of the code I haven't written, and I've taken it from some of the various websites that I recommend or made some small changes to it. And where I have done, I'll give you some references like I've done here for you. Okay. So what happens is that the singleton class defines let's look at it on the left here. So we have a class singleton on the right here. And as a private constructor, okay, and we've seen this before, it creates a static property called singleton, which deals with an internal object called instance, and that internal object is an instance of the class itself. And then, when we access this property using the getInstance method, it's a static method, as you can see. Then it just returns the instance. So every time we get the instance, we're always returning it. So what happens is, of course, is that in terms of the first time we get there, if the instance is null, then it hasn't been instantiated yet. And then so we instantiate it and create a reference to that instantiation as _instance in this particular case. Otherwise, we just return the existing instantiation. So we're controlling the creation of the object, which is a singleton, which has a singleton pattern. Now, we don't have to call it singleton. It could be anything we wanted to call it, and it just will be implemented as a singleton. But this is the basic form. You may have some logic in here as well. I took this particular example from the Singleton and C# and from the Dive into Design Patterns textbook. And you can see that if you were to create a singleton S1 here or singleton S2, then what happens is that you just get the instance, and if you tested S1 and S2, you would find that they both refer to the same instance of the object. What we've done is this one here, this key word new, okay, is crucial really as to what we're doing with design patterns, creational design patterns. We're hiding that new. We're making sure that the user who wants to use this class doesn't get to create new objects by themselves. It just doesn't happen. Okay? So really, the singleton's constructor really should, and of course this is an alternative to you using and accessing the constructor yourself, okay? So the singleton's constructor should always be private, should always be parameterless, and this prevents direct construction calls with the new operator, and that's the core to the creational design pattern here. The instance is stored in a static field, and there are multiple ways to initialize that field, and they have lots of pros and cons of this, and we see them as we work through this class. And this example shows the simplest of these ways. It doesn't really work well in multi-threaded environments, because what happens if there's two threads of execution that want to access the singleton or to do this? Let's say we have two threads, and one is issuing S1 and the other is issuing S2, and the call to S1 happens in the middle of this particular if statement here.
you could actually end up getting a second reference. So it's worthwhile checking. And that happens could happen in multi-threaded applications. And you're saying, well, what's a multi-threaded application? Well, anything, if you have multiple windows that are running on a phone or in an app or something, you could have multi-threaded apps. You probably don't write multi-threaded apps, or maybe you do in your operating systems module, but it becomes an issue and we need to be aware of it. So get instance here, that is the static method that controls access to the singleton instance. So on the first run, it creates the object, places it into the static field, and then in subsequent runs, it returns the existing object stored in the static field. So any singleton also should define some business logic. In other words, what does it actually do? And you could have that by creating a static void method here called some business logic. Note actually what's important here is that even though you can create an instance of the singleton with the static void method, you can't actually use the instance to call the method, and you can see a demo of this working. So maybe we have a look at this, and we'll have a look here. So I have a couple of examples in the code, one called my singleton that I can give you. So we'll go into this. Now I know from some of my earlier examples that this will give us some problems. Okay, so I have some problems down here. Okay, I'm getting this issue because I moved from one computer to another computer. Let's just look at this particular one here. Sorry. So let me just do this. Show you what's happening here. Okay, so what's happening is that I'm getting this error here. This particular installation of .NET on this machine expects me to use this target framework here. Okay, but when I developed it on my other machine, I was actually using the 5.0 framework. So I just have to change this, save this, and I get rid of this here. I'm not interested in that. Okay, and here is my singleton. Let me just run this, and let's switch over to Zen mode again. Makes it a little bit more easy for us, and we try to make this a little bit bigger. So I shouldn't get the errors that I would have had. Those you might have seen all that red text earlier. That basically was because I was working with on my development machine, and this is my presentation machine. The presentation machine isn't really up to date with its latest version of .NET. Okay, so I have a singleton references are equal. So what happens is I created S1 and S2. So let's go down to our program and have a peek. So the singleton was the singleton that I just used earlier. So I created a singleton class, and I created an S1, which is an object of that type, and I got a reference to the instance using singleton.getInstance here. And then I had S2 as well, and then I made a test to see if the two instances were equal. Sometimes you'll see if S1 is equal to S2 or something. They're not null and all this kind of stuff. But this is a nice way to test if object references are equal, then the singleton references are equal. If they're not, the references are not equal. Now it would be difficult for me to produce something that could violate this, for example, with multi-threaded thing, and make it simple for you, but I'm not going to worry about that. I'm also doing some business logic, so there's not doing some business logic here. I would have to call, now we can go up and have a peek at this. Here's a singleton. What I've done is I've used the example from the refactoring guru, and I've left in a lot of the notes, and I've added in some of the notes for you so you can work through them. But here we have a we're using protected singleton we could use private. I think that they use private on the the website, but I just changed it to be protected to show you that I just prevent subclassing. And then I have my private static singleton, and this is the test. You know, if it's not null, we can check if something is a new singleton. It's easy enough to do this. And then we have some business logic, which is public static void. So business logic, and it just writes this. And then I had another one, which was public. This is a public static void, and this is a public void. So what happens is that in the example that was given in the textbook, he used public static void. And then the examples he would have called would be, you know, said you can call this business logic, you know, in the instance, but you couldn't actually do the S1 dot some business logic. It wouldn't work because you'd have to use the actual singleton dot some business logic method. So in order to show you how that works, I added this additional method, which is just a public void. It's not a static function. So that means you can actually access this from the instance. So that's why I'm getting hello from the singleton static and hello from the singleton public. And it's because I created the two instances here, okay? But if I tried to actually, if I tried to do something like this, it may give me some issues. Okay. Oops. Okay. So I need to, I just have to be careful that I'm calling the singleton class here. Okay. So that looks fine. So that's really all we need to know about running and starting with our singletons. So let's get back to our. Okay, so what happens then if we want to make things for our singletons thread safe? Okay, so what we want to do then is, and I'm not sure, maybe you can inform me in chat, but I think you may have done some of this in your operating systems type work, because a lot of the time you do locking and or in networking, you may have come across using a mutex to make sure that only one thread is allowed to run at the time. So we can use this mutex, okay? We still might be locking each time, you know, with this singleton. Doesn't seem right, okay? So just if you haven't done this work before, so a mutex is a mutually exclusive flag. And in this example here, there's one called lock object. And that acts as a kind of gatekeeper to a section of code. And it allows one thread in and blocking access to all others until it's released. Okay. So this ensures that the code being controlled will only be hit by a single thread at a time. You have to release the mutex when you're finished as well. Okay, it's probably a good idea to do that. In C#, then the lock statement acquires the mutual exclusion lock for a given object. It executes a statement block and then releases the lock. So this lock, create the mutex, locking it and unlocking it can all be done in a block. That's locked. Okay, so lock and release. So you don't have to explicitly release it when the block finishes. And here then it's gone. So while the lock is held, the thread that holds the lock can again acquire and release the lock. So any other thread is blocked from acquiring the lock and waits until the lock is released. And this happens just once, okay? It only happens once. But you can be sure and check in the multi-threaded application that two threads, you know, again, happens around about this point here in the program, okay? Before and here and before the lock occurs. You know, we might have two threads, and depending on how fast they're running, it becomes an issue. Okay. So, have I some more information on that? No. Okay, so this time you'll notice I've used a public sealed class. Okay, again, you know, if a class is sealed, it can't be inherited. So there's lots of ways to ensure that there can only be one. We don't want a subclass, the singleton either. So, and again, I have a public static volatile thread safe. This is a thread safe singleton instance, and an object, lock object, was just some new object, and it doesn't matter what it is, it's just there in order to be able to do some locking. And again, we just create a thread safe singleton. It's the exact same as before, except this time we're locking using this mutex, which is the lock object. So it's not too bad. It's it actually works quite nice for a thread safe singleton. Now, notice the you may not or may have noticed that the instance equals null is done twice. Okay, it's done twice. Once before the lock is acquired and once afterwards. And that will be thread safe even without the first null check. Okay, but it's just makes it a little bit better. But if you had it without the first check, then it would mean a lock could be acquired every time the instance is requested, and that would cause performances to suffer. So the first null check is added so that the lock is not acquired unless it's necessary, and the second null check makes sure that only the first thread to acquire the lock then creates the instance, and the other threads will find the instance. Yep, they'll find it because this won't be null, and then the instance will be populated, and they can skip that instantiation part of this here. Okay, so this is how. Once this is fine and done, it just helps speed up. So really, what's happening here is that we might have so what's happening is this is design, some change to how we represent this because we want to try to get better designs. We're all the time trying to make our code a little bit more elegant. We're trying to have code that works fine, does what it's supposed to do, doesn't do any more. All of these good design principles that we want to utilize. So I've done this. If we go back to our program, so you will notice that which one is this? That's my lazy implementation. Let's have a look at my Singleton here. So I've got a thread safe Singleton in here for you as well, and I can create a thread safe Singleton. Okay. And that just gets an instance, and it works the exact same way as my previous Singleton one did. So this was my Singleton class, and if I scroll down through this code here, you'll see that I also have a thread safe Singleton. Okay, and again, it's working in the exact same way as we just had on that side. So you can work and practice and have a look at this. Okay, so that works fine. Okay. So how much more can we do? You probably ask yourself, okay? So let's look at making it more elegant, even more elegant, okay? So there is a version of the Singleton that is thread safe, but elegant, okay? Much more elegant. And it's called, often referred to as the statically initialized Singleton. And, elegance is, it's a much overused word, but we want something that works very, very simply and works really, really, uses the best implementation that's unambiguous. And, we use the keywords where we can and what's built in. So here we have, why is this thread safe? Okay, it's because in this case, the instance object is initialized using a static constructor. Okay. Private read-only, we have a public class here, we could see these. Private read-only static Singleton is a new Singleton. Okay. So this read-only static, okay, is what does the work for us. Okay. So the CLR, okay, and that's the common language runtime, and that's the virtual machine component of the .NET. So when we say .NET Run, we're essentially launching the CLR. Sorry, excuse me. And then that manages the execution of our .NET programs, and it's very similar. It's essentially the same as the JVM, the Java Virtual Machine, which you'll be familiar with. Now you're familiar with this, but you probably didn't know it was called the CLR. Okay, so the CLR, its job is to ensure that all static constructors are executed thread safe. So here we have a static constructor, okay, and it's thread safe. That's really nice. Okay, and that gives us thread safe stuff. So some note that would be useful is that if you have an immutable object, that's one that can't be changed once created. For example, in C#, strings are immutable. So if you look at string manipulation routines, you'll see that all of them return a new modified string and leaves the original string unchanged. So that's their strings are immutable. So using read only here means that the reference cannot be changed once it's set, and that can only be set during the object's construction. So this static initialization also means that is thread safe. So this private, well, in fact, it's private. The static the read-only static or static read-only, you can invert them if you wish, is what makes it thread safe, and it's quite elegant. Okay, and you probably have to do a little bit of work and research to understand why this is more elegant than this. Okay. Okay. Actually, I see an error here. I see an error. Does anybody know what the error is in this? Anybody tell me maybe what the error might be here in this particular piece of code? No? Okay. It's got to do with the name, you know, here. It needs to refer to itself. Okay. Okay. I mean, I expect if I go to the actual code and look at the code, and we look at the thread safe static singleton here, you'll see that I have it correctly named. Okay. Okay. And here. Okay. So it's fine. Okay, but just for this particular example, that would have given us an error. Okay, if we were to copy and paste this particular code, but of course I've given you the actual code separately. Okay. So one of does anybody have any questions about this? We can go to the code and have a quick peek there and see what's have a look at this. So here I have I hear what's happening. Maybe you might be unclear about this or might remember this. Okay, so if I have a public static thread safe singleton gets the instance, this is my definition of the property here. Okay, so so this is my this is my definition of the property. I've just made it a little bit bigger, maybe a little bit easier to read. So public static thread safe singleton get instance. This is defining the property here, and I'm using this arrow notation as well. Okay, and this is the lambda expression, and it's an alternative way actually just for setting a static read-only get property. So it's equivalent to this public static thread safe get instant get the new static singleton. Okay, so we could do it that way if we wanted, and that would be fine. This would be equivalent to this, or we could also do this: public static thread safe singleton static singleton get instance, and set up it this way. Okay, so we could do that if we would replace this line with this line, 93 with 98, and again we could have an alternative as well. Okay, so that's how they work. So you've seen me talking about lazy singleton. So what's laziness got to do with all of this? So let's go back to this. So let's think about lazy initialization and design patterns. So lazy, as opposed to eager initialization, is a technique that defers the creation of an object until the first time it's needed. In other words, initialization of the object only happens on demand. So in the case of the singleton, when we need and provide access to something, some resources, then we don't actually load up all of those resources in our program until the actual singleton or global variables, for example, are actually required. So it helps with the memory management of our apps. So by taking advantage of lazy initialization, you can improve an application's performance by avoiding unnecessary computation and memory consumption. So you can write your own custom code to implement lazy initializations, and sometimes you'll see an example for C#, and it says here's a lazy implementation, and you're wondering, well, why is that lazy implementation? A lot of the time it has to do with the use of static and properties, and it might not be obvious to you that that's lazy or not. But I prefer Microsoft's recommendation, and we use the lazy T class. Okay, so lazy T class is a system namespace in C#, and it was introduced in .NET 4. So that provides a thread safe way to implement lazy initialization. So So definitely worth using, definitely worth doing. When you use the lazy class, lazy T class, you need to specify the type of object you intend to create lazily in the type argument. Lazy initialization occurs when you access the lazy T.value property. So all this does is allows us, and it's a wrapper essentially, around the existing objects that tells us, you know, let's initialize those in a lazy way. So for example, here's a nice example, and I've taken this example from this article here on how to perform lazy initialization in C#, from Joydeep Kangila. Okay, it's a fairly recent article as well. So they say that, let's say you've got two classes, an author class and a blog class, and they look a bit like this here. Author has some information and creates blogs, and so an author has blogs, and you can see that there's a list of blog entries here included. So this class has this class. It's just the relationship here in terms of the UML, if you want to start thinking about this. Okay, but so let's say some app that utilizes these shows the author details, but it doesn't actually show, so you can list through all the authors that you might have and then look at their blog details. So you don't load those details unless they're actually requested. It would be much better to have a lazy design here, because this actually, every time we load the author, it loads all the blog information. And you might think back to some of your CS230 designs when you were looking, and we were looking at some examples where we were trying to find information about clients attending therapists, and we would have seen situations where, you know, we have declined information, and then we want the list of all of the actual sessions, therapy sessions that this client had. So we could have added all of those into the actual designs as well. We could have just had some referencer list, and then we load the lists of sessions afterwards. So now an idea of how we might look at thinking about lazy and eager initializations. You know, we want to load all the sessions at the same time as we load the author or the patient details. As we skip through an interface that tells us a little bit about the personal details of each of those, we access that information as we require them, and that's kind of like a lazy initialization. So really, the list blog here, okay, that's a generic collection that's been used in author to code, in this code here. It would be much better to use a lazy T class here. So we need to wrap this to say, no, actually don't load all this straight away, let's load it a little bit later. And that later is when we first access. So for storing the actual blog, we use this list T, but because you actually need a concrete class in order to be able to do that. If you return it from a property or require it as an argument, it's always best to consider using an iList T, as we've seen here. Okay, lazy. Here we've got the iList blog rather than the list blog. We're wrapping a lazy around it, so the T, if you like, is the iList blog in terms of the generic sense here. Okay, so that just, we use this lambda again to have a function that returns a new lazy blog, okay, and that actually gets information about the details for the author from this. So it's fairly straightforward here, and you're nesting lambdas here, and that's, you know, worthwhile. And if you need to figure out how those lambdas work, I've shown you a little bit on the next slide here. But so then we have the details. We can get the details for the author here, so we're just calling this function here. This is a parameterless function that just returns this, and that returns a list of the information or the blog. So I've just I've looked at this. As I said, this example is in this particular article, but he says to code here to retrieve all of the details, but doesn't give the code. So I've given you an example of how you could actually make that happen myself. Okay. So anyway, this is generic. Okay, so we use the iList as we used alongside. It's more generic. It allows more types to be passed to the argument. It allows more types to be returned than just list, which is, you know, which is useful if the internal implementation changes. Remember, list is a class that represents a list of objects, can be accessed by index, and iList is an interface that represents a collection of objects that can be accessed by an index. Okay, so concrete class, index. You can't actually do, you know, iList blog Singleton new iList blog because you can't instantiate an interface in this way. Okay. So now let's look at a lazy thread safe singleton. We're pulling it all together now. So, and we're redesigning, and this is what we end up doing. And I suppose the whole purpose of this module is about software design. And you need to know about, well, if I look at a piece of code, can I make it better? Is it a good design? And these are ways, some questions you ask. Am I using lazy initialization here if necessary? Am I managing the creation of the objects? Am I separating that from their usage? Or do we just create objects anywhere I feel like it's using new? What about thread situations, where I have multi-threaded environments? These are the things you need to start thinking about. And as you work through and become more experienced in software design patterns, you'll see a lot of the time, you'll see real world applications that are thread safe, that do all of these things. And it'd be worthwhile looking at those. Okay, so really for us, we can see that lazy initialization is really an excellent performance optimization technique. And that allows deferring the initialization of objects that consume significant CPU or memory resources until you absolutely need them. That's the whole purpose of laziness. So we can take advantage then of lazy initialization to improve the performance of our singleton pattern. And that's achieved by passing a delegate to the constructor, which calls the lazy singleton constructor. And that's done with the lambda expression. So this is how we do that. Private static read only, we've seen this already, because we're looking at the whole thread safe stuff here. And then we have a lazy singleton instance, and just creates a new one. So it's of lazy singleton, and that's fairly straightforward. And that lazy singleton get instance just returns the instance.value. So it's very, very nice. We have the constructor, parameterless constructor that's private, can't be called from outside, even the public class here. Remember, this line of code here, you'll see it embedded in here. I've just taken it out here. That's a lambda expression or lambda function, which returns an anonymous delegate with no parameters, and it's equivalent to this delegate void, no brackets, here, void function that returns a new lazy singleton. So this is how we make our singletons lazy, and this is here, and this is how we make our singleton thread safe. So that's it. We use a static read only to ensure thread safe operation. Okay, so we combine the two, then we get this lazy thread safe singleton. Okay, now that said, this singleton does nothing. Okay? It does absolutely nothing. But we could make a singleton that does something more useful, and we'll see one just at the end of this lecture. Then it would actually be interesting to see a real world application where the difference between using the first one, where we had that simple lock, and one using this faster solutions that that implements as lazy thread safe work. Does it actually make a difference? Okay, does it make a difference in performance? How do we do that? How do we test it? Because it's difficult to test these singletons, because of the way automated test software works. But I guess what I want you to think about here is the main idea of the discussion so far was to talk about design. Okay. And I want to have you thinking about design. When you start working with your classes and your programs, I want you to think about, well, is this a good design? It's a very simple thing. You should be able to reflect on your work and think, well, is this a good design? Am I happy with this? Am I happy to give this to somebody, to a client? Am I happy to have this working? Will it work? What circumstances will it not work? Am I making best use of the language features? And you could be doing this in Java, and you'd have similar issues. Again, these are bigger than just the language itself, and you'll find that there's a way to do thread safe lazy singletons in Java as well. So it's fine. And I've read a wonderful article last week, a 3-part article on using creational design patterns in iOS for iOS development. So, it's everywhere, and you need to get it. It's the kind of things that comes up in interviews all the time. And you're better off, rather than having a smattering of, I know a little bit about all the patterns, really understand one pattern or 2 patterns and see how it works. Okay, so that pattern then, just to review, we're interested in singleton. And it would be important, of course, and we can have a look at the singleton again. We know this is the class diagram for that, understand it. And there's some information about how a note and how we make it happen. Okay, but the aim of the singleton is to disable all other means of creating objects of the class except the special creation method. And that method either creates a new object or returns the existing one if it's already been created. Some advantages here, and I took some of these advantages from this blog here on the Singleton pattern pitfalls. Really, really nice articles, worth reading. And the advantages include, you can be certain that a class only is a single instance, you gain a global access point to that instance, and the Singleton object is initialized only when it's requested for the first time. The disadvantages, and there are always disadvantages, you know, to things, as a lot of these are context dependent, you know. It may be difficult to unit test a singleton. I mentioned this earlier, clients, because many test frameworks rely on inheritance when producing mock objects. So it requires some kind of creative way to mock the singleton. Or just don't write tests. Don't test it. Or don't use singleton, you know, at all. So, you know, who says you have to use singletons? You know, there are other ways to design and do this work as well. And I'll show you a little bit about where to find information on that a little bit later. But you know, you always have the choice not to use the patterns. Okay, you might trust your colleagues to not use you in strange ways and not to create more than one instance of something. You know, you might trust the team. You might be very disciplined. You might be the team, and so you know yourself that you're not going to make those mistakes. Okay, so yeah, there's some complexities around that. So, but another and more important disadvantage of singleton, to try us back to design again, is that it may violate the single responsibility principle. And I mentioned that earlier in the lecture. I said that the singleton is doing two things. Okay? It solves two problems at the same time. So singleton is doing two problems at the same time. It doesn't have single responsibility, so it violates this solid principle. So the first is the class's primary function, okay? So we haven't actually talked about the class's primary function. Whatever it does, it does. But the second is to ensure that only one instance be created. So a strict interpretation of the SRP would suggest that one of those responsibilities should be moved out of the class. So if you do that, it ceases to be useful as a singleton. Okay? So there's this variance between the good Gang 4 type design patterns and our solid perspectives on what's a good design. So one is a good design and the other is a good design principles, and yet the principles are contrary. But really, you know, principles are not laws. Okay, you know, you can choose to ignore them if you want. But the benefits of the singleton may actually outweigh the subtle influence of an abstract principle. You will decide that when it comes to your actual implementations. So we have to think more and need more than just the SRP to make a case for avoiding singleton, however. So what I would do is I would recommend that you check here for a counter discussion. It's a link on not breaking the, it says that, well, no, actually this doesn't actually break the SRP at all. You just think it does. And in fact, a lot of this is all contextually dependent. So this is a really interesting article here for this. What I would do is Uncle Bob has an article, Robert C. Martin, on the Clean Code blog, and there's two entry points to it. I've given you just one. And for example, he talks about singleton versus just create one pattern. He doesn't seem to be a fan of singleton, even though he's one of the people who are involved in the design. But so I recommend maybe at some point, if you have a few minutes, maybe have a look at alternatives to singleton, and you could try that and see how it works. So we're near the end of the lecture now. So let's have a quick look at a real-world singleton example. So load balancing is a process for distributing network traffic across multiple servers, and that ensures that no single server bears too much demand. So by spreading the work evenly across the whole application, the web, it spreads it evenly. It improves the application responsiveness. Okay, so it also increases the availability of applications and websites for users. So modern applications cannot run without load balancers. That's just any web stuff you need to know. If you're doing back-end web things, we never got to it in our CS230, which is a bit more advanced. But you actually really need to understand and work with load balancing. So over time, software load balancers have been added to replace hardware load balancers. They have lots of additional capabilities, including securities and applications. It's a really good article on this by AVI Networks, and they're now VMware, really, and it talks about load balancing if you want to find a bit more about this. But there are lots of approaches to load balancing. How does this load balancer work? So there will be lots of different algorithms, and in fact, there's a nice list of the algorithms in this article here. But the different algorithms depend on different situations. So here's some real-world code then that demonstrates, and this real-world code is from the dofactory.net. They're a great website, a really, really good website, and lots of information about real-world design patterns. So this real-world code creates a load balancing object, and that is a singleton. Okay, it's not called singleton, but it's a singleton because of the way it's designed and worked. And you'll see, if you notice some of the internals here, you'll see how it's working here. And this says that it's a thread safe. This isn't an audit. Why is this a thread safe? Well, this particular one wasn't, but it has an example. Anyway, dofactory.net. They say they're a development company, it's changing development, but I don't know anything about them, apart from the fact they provide a really excellent overview of the software-defined patterns. The link is here, and the structure, what's nice is they provide both structural and real-world examples. And the singleton example is here at this link. Click through and you'll find it. I've downloaded it and tested the application, and we can see it running VS Code. It works really well. In fact, it gives you 2 examples for the singleton. So I think I did both. And really, it implements a factory. Let's go back here. I think I have my load balancing here. We probably get some kind of error here again. Let me. Copy this. I just know it will fail if I because I did take that from my other machine. You can see that the error has gone away now. This is the load balancing program. Let's go back into Zen mode. And here we have the load balancing. As I said, I didn't write this. I took this from the dofactory.net example. This is the load balancing one that has a singleton. This is eagerly initialized, but it says in the actual description that it's thread safe and that it's lazy initialization. So you'll have to look at that yourself and decide whether it really is or not. But we can see how it goes. And so it has a bunch of servers here. And creates essentially a load balancer that accesses a server, and that's all it does. It's the main app is here, just gets a load balancer, they're all actually the exact same instance. Okay, but so now we want to actually make 15 load requests to the balancer, so we know that there's the balancer here, and that's just a test to show that it's all the same. And then we dispatch, so we get the next server name based on the load balancer. That's centrally managed to tell you which server, so we can run this. We should get a list of servers, 15 servers, okay? Yep, and we do. And it's all handled centrally. So it's a really nice real-world example that you could look at and get a sense of how does singleton work in practice. It's also really useful. Singleton is also useful for logging, as well. Okay, so we learned about singleton. That's one of the GOF creational software design patterns. We saw some examples of implementation using C#. And the next lecture will deal with the factories. Okay. Thanks very much for coming. I appreciate that. Sorry, a little bit over there, but it was worthwhile getting that final example in. All the code will be available, and you can I'll put it up and notify you and work from there. Thanks again. Have a good day, and I'll see you next time.